Hello. For today's session, we are going to learn about design of singly reinforced RCC beam. After completion of this topic, the students will be able to design the singly reinforced RCC beam, that is, determination of reinforcement required for the singly reinforced section. As already we know, the different assumptions we have made for analysis and design of reinforced concrete beam, we are supposed to learn about how the stress and strain variation is in limit state methodology. So in case of working stress method, we find variation in stress and strain which is linear, whereas in limit state method, first we find the variation is linear, but afterwards the variation in stress is rectangular and then parabolic in compression zone. In both the methods, we assume one important thing, that bending compression is totally taken by concrete, that is entire, and tension, that is entire tension borne by the steel. So reinforcement takes entire tension, so concrete is unable to take any tension because its flexural strength is very less. Now we'll move towards the design of reinforced concrete beams. In this case, the span, the loading of the beam along with the grade of concrete and steel are given. One has to determine the area of steel on tension phase. Now below is the stress strain diagram of singly reinforced section. Now just go through the diagram. The diagram explains stress and strain variation in singly reinforced section. Singly reinforced section is a section where the reinforcement is only in the tension zone. At the bottom you can see the strain is linearly varying. Maximum strain in concrete is taken as 0.0035. The strain in steel should be lesser than that, so that the steel will fail first and the failure which is in ductile failure and not a sudden one. The stress variation in the compression zone is a combination of rectangle and parabolic, that I have said earlier. The stress in compression zone is taken totally by concrete. The stress in tension zone is taken totally by steel, so that the force is shown in the tension only where the steel is provided. The moment of resistance of the section can be obtained by multiplying the lever arm with a tension force. If we know the maximum moment which is going to occur in the beam, then by equating moment of resistance to maximum bending moment, we can find the area of steel required. Now we'll move towards the total design procedure. Now assume first the width of beam as a B, then find the effective span L suffix C, where L suffix C is LC plus D. LC is the clear distance between the supports and D is the effective depth of the beam, and LE is LC plus width of the support, the minimum of above two length which is considered as the effective length. Then go for design of bending moment M suffix U. So MU is equal to 1.5 multiplied by WD, that is dead load plus live load, into L square divided by 8, that is WL square by 8. Then MU limit, that is 0.138 FCK BD square, that is for FE415, and 0.133 FCK BD square for FE500. Now compare these two, that is MU and MU limit. If MU is less than MU limit, then and then only design for a singly reinforced section. Find the area of steel by G 1.1 B of IS, that is using IS 456 2000. MU can calculate by this formula 0.87 Fy AST D into bracket 1 minus AST multiplied by Fy divided by BD upon FCK bracket complete, which will give us the area of reinforcement AST on tension face. Mu, which is required for this calculation, that is 1.5 into WD plus WL into L square upon 8, that we can keep here and we can find out the value of AST which is required for us. Thank you.